Good evening, all. We are super excited to have you all here. Today we have Kemila Silva, who is a DevOps engineer. He's going to talk about Prometheus Federation and Thanos. Kemila, screen is yours.
All right, thank you, Chamo. Thank you for the introduction. So let me share my screen first. I hope you can see my screen.
Yes.
All right. So yeah, hello everyone. So today's webinar, I'm gonna talk about Prometheus running on federated mode together with Thanos and monitor multiple K clusters. And also, I would like to showcase a demo about how do I deploy Thanos along with Prometheus and Grafana to Kubernetes clusters by using Helm charts. So, yeah, I'm Kemila De Silva. I'm a DevOps engineer. So you can reach me on Twitter, LinkedIn, and you can read my articles on Medium. So that's pretty much about me. All right. So let's get it started. So Thanos. Yeah, so Thanos is a popular solution to provide in a distributed high availability global quality view of metrics and long-term storage for Prometheus. With the expansion of Prometheus instrumented to Kubernetes clusters, some limitations come to our picture. Here you can see some example. How to query metrics across multiple clusters. The first thing, just imagine you deploy Prometheus on 50 clusters and you don't want to jump between Prometheus instances to query metrics for each cluster. And the second thing, how do we store metrics for long-term use by default? As we all know, Prometheus has a retention of 15 days by default. So if I ingest some metrics, these samples are kept in TSDB for 15 days by default. The question remains, what if I want to query the data from several months old? And the third thing, what if for any number of reasons Prometheus goes down? What happens to our entire metric system? So Thanos was born to overcome those issues. The whole point of Thanos is to try to combat some of these issues that we can see when you are scaling Prometheus globally, when you are scrubbing hundreds of thousands of different clusters, and its core Thanos consists of number of composable components that you can use to bring scalability, high availability, long-term retention on top of any existing Prometheus setup. So Thanos is completely Prometheus compatible. It is built on top of all of the great design principles of Prometheus to leverage all of the knowledge of running Prometheus. And yeah, so it's provide global view of metrics where we can see metrics from all our different clusters. And also we will have long-term retention. So we can query those metrics from several years ago from all our clusters, but also we will be able to see data down to the individual sample, even if like a year ago. So when we move on to the normal architecture of together with Kubernetes and Prometheus. So as you can see in here, we have three separated clusters, and each cluster we have to install Grafana, Alert Manager, Prometheus, and we have a notification provider. So in here, this architecture is Slack. You can use Google Chat, MS Teams, likewise any notification provider. And each cluster connected to the local storage. So when you are deploying Kubernetes infrastructure for our customers, it is standard to deploy a monitoring stack on each cluster. So this stack is often to comprise with several components. So as you all know, Prometheus is to collect metrics and alert manager to send alerts to various provider based on metrics query, and Grafana simply for fancy dashboards. So when we move on to the real architecture of Thanos, Thanos follows the similar idea. So as you can see, pretty similar to the previous one. So we have three separated clusters, and this Prometheus also connected to something called Thanos Sidecar, and there's something called Thanos Courier, and uh, yeah, and in this cluster only install Grafana, and all three clusters connected to the object store, and we have a notification provider as well. So Thanos follows a similar idea. So as I said before, Thanos Courier, and which is the key entrance of the middleware, that client doesn't query Prometheus directly anymore. Instead, the requests are sent to query first, and Courier deals with each distributed Prometheus instance via gRPC interface called Store API to aggregate data, which means collect data, and present back to clients. So all the Store API does is to expose the distributed data. So when we speaking of data, the most important one is the local storage. In each Prometheus cluster is exposed by a sidecar. So this sidecar is able to read the data on disk, and Thanos Courier calls the Store API in the gRPC interface to collect data. So as you can see in here, so in this real Thanos architecture, different components talk to each other via Store API, as well as you can see in this real architecture, components possibly send data to the remote object storage directly. So yeah, so all right. Uh, then we can move on to the demo. So to set up this multi-cluster monitoring with Thanos, Grafana, and Prometheus, I have set up three separated multi-node Kubernetes clusters on a DigitalOcean environment. So these are the clusters. So two clusters act as data producers. So these are the data producer clusters, which will host the Prometheus deployment and applications that expose metrics via Prometheus. And the other cluster, which means the main cluster, act as data aggregator, which will host the Thanos and aggregate the data from data producers, which means these two clusters. And this cluster also hosts Grafana for data visualization and reporting. So today I have everything set up. So I'll explain how I done this. First of all, we need to configure kubectl and Helm3 package manager on package manager to all our Kubernetes clusters. So I have connected all three clusters to my machine using Docker Hub. So then I can simply switch between all three clusters. All right. So I hope you can see my terminal. Do I need to zoom in? Come on.
Uh, Kemila, can you zoom a little bit?
All right.
Yeah, that's enough.
All right. So, yeah, let's see kubectl is working on mine. Yes, kubectl working, and let's check out my Helm version. Yes, Helm 3, all good to go. So as a first step, we need to install Prometheus operator on each data producer cluster. So this Vietnamese Prometheus operator chart provides easy monitoring definitions for Kubernetes services and management of Prometheus instances. And it also includes an optional Thanos sidecar container, which can be used by our Thanos deployment to access cluster metrics. So yeah, as a first step, we need to add Vietnamese charts repository. So I have already added that one as well. So here I'll show you how the command to do that. Here's the command. Uh, and also, let's do it on my browser as well. Repo list. Yes, Vietnam is already added. So then we can simply install Prometheus operator on each cluster, each data producer cluster. So I'll first switch to the data producer first cluster, right? Uh, let's see, cluster is working. All right, cluster is working. So to install Prometheus operator using Helm charts, you can use this command. So yeah, when you are deploying, make sure to add a separate external labels for each data producer cluster. So in here, I have used as a first cluster data producer -1, and as a second cluster, I have used data producer -2. So when you are deploying this Prometheus operator using Helm charts, this Prometheus Thanos create parameter creates the Thanos sidecar container, while the Prometheus Thanos service type parameter makes the sidecar service available at the public load balance IP. So this makes it easy for Thanos to access Prometheus metrics in different clusters without needing any special firewall or routing configuration. So, however, based on articles which I have read, this approach is highly insecure and should be used only demonstration purpose. So in production, it's prefer to deploy Nginx ingress controller to control access from outside clusters. So then I'll show you how I install Prometheus operator on my data producer cluster. So let's get kubectl get pods. All right. Prometheus operator is up and running. Okay, then I'll show you how Thanos sidecar container running inside this Prometheus operator. So I'm going to copy this pod name, kubectl describe pod. Yeah, so let's see where Thanos sidecar. Yes, so as you can see, so Thanos sidecar is up and running. So inside that Prometheus operator pod. So and we need to get that load balance IP of Prometheus. So I'll get that one as well. We need to copy that load balance IP because we need that in Thanos configuration. So I'll copy separately. All right. So once we done that part, so we need to do the same thing for our second data producer cluster. So I'll quickly switch to second data producer cluster and check it all good. kubectl get pods. Yeah, Prometheus operate up and running. So I need to get the load balance IP as well. So I'll copy that one. So this is the my first data producer cluster load balance IP, and this is the second data producer cluster load balance IP. So yeah, once we done up to that, so we can we can move on to the second step. So as a second step, I'm going to install and configure Thanos on my data aggregator cluster, which means the main cluster. So on this step, I'm going to install Thanos Courier and integrate it with Alert Manager and Minio as the object store. So first, I'll quickly switch to the data aggregator cluster. CTL. All right, cluster is working. All right, so for to deploy Thanos Courier and Minio, so we need to create a value.yml file. So in here, I have already created that one as well. So I'll show you that one. Cat is dot. So here's that values.yml file. So you can simply, I'll share that link. So you can simply copy that the whole values.yml file using that kind of a VMware article. I'll share that one as well. So in this values.yml file, we need to put that load balancer IPs of data producer clusters in this stores category. I already had that one. So as you can see, all IPs are correct. So yeah, and also we need to put a access key for Minio and secret key for Minio as well. So when we, then we can install the Thanos Courier using Helm command. So here's the command to do that. So by using this command, you can simply install Thanos and you can pass that values.yml file as well. So once we done that part, you will get this kind of a response. So I got a screenshot of that. So you need to copy this fully qualified domain name because you need that in Grafana configuration. You need to copy that fully Thanos Courier DNS name with the port. So yeah, once we done that up to that, we can check it on my browser. I don't think and also one I couldn't mention that. So when you are deploying, please make sure to when you're passing that values.yml file, please make sure to add correct namespace in here. So otherwise, all pods gonna be crash. So in here, I do everything on my default namespace. So if you are doing on monitoring or any other namespace, please put a correct namespace here because in the initial time I was wrong. So I put the monitoring namespace. Then I sort it out. Yeah. So please make sure to add correct namespace in here as well. So let's see my Thanos is working. So yeah. So Thanos is run under 99 port. So this is the Thanos UI, pretty similar to the Prometheus one. So once we done up to that, we need to check each service displays a correct unique cluster label set, which we configured in this step. So as I said before, so I put for my first data producer cluster, data producer -1, and second one data producer dash 2. So I think in here, so for my first cluster, data producer dash 1, and for my second one, data producer dash 2. Yeah, so then all good to go. So then we can simply install Grafana on my data aggregator cluster. So yeah, I think this is a command to do that. By using this 7 command, you can simply install Grafana. So I have already done that part as well. So I'll show you how I done this. Let's see my Grafana. What is up and running? Yes, Grafana is up and running. So I need to get the load balance IP. Yes, to copy that one. So let's see on my browser. So yeah, so Grafana is up and running. So then we need to configure Grafana to use Thanos as the data source. So in here, I have already added that part, but I'll show you how I add it. So you need to go to the settings category and go to this data sources part, and you need to select data source as the Prometheus, and you need to put that fully qualified domain name which we copied uh, in here. You need to put that domain name in this URL category. So yeah, once we done that, we can test our data source is working or not. Yes, data source is working. So to test this, I have already imported Prometheus node exporter chart, because in each data producer cluster already running node exporter. So here's my node exporter chart. Uh, by using this node exporter chart, I can simply I have three node two data producer cluster, and so these are the whole nodes, 6 nodes. So I can simply monitor all 6 nodes here. So, and also I would like to showcase how object store running on my browser. So as I said before, let's clear all this qctl get faults. Yes, so as I said before, I use Minio as the object store. So in the previously, I put that values.yml file object store configuration. Though, so or Kubernetes store all those configuration as a secret. So I'll show that one as well. Ctl get secrets. So yeah, I'll show you this object store one. Ctl edit secret. Yeah. So yes, so this is the so they encrypt all these configuration. So I can simply copy that part and let's decrypt and see what they show. Go 64 dash B. Yes, so as I said before, so all these configurations they kept as a secret. So this Minio runs on my browser as well in 9000 port. So I'll show you that one. Yes. So this bucket name Thanos, uh, and these are all the objects. So you can simply uh, going into that and you can download if you want. Uh, yeah. So as a summary, what I can say, now you can simply deploy more applications to your clusters as long as you can enable Prometheus metrics and Prometheus operator services to monitor for each deployment. And Thanos will continuously receive and collect the metrics, and we can inspect that using Grafana. So that's the whole point of doing this webinar. So yeah, I think, and also you can, if you want, you can use these object storages as well. So these are the supported object storages in Thanos. Yeah, that's all about it. Uh, I hope you will get something. So thank you very much, Community Sri Lanka, for this session. And also, I would like to thank you, Nilesh Janandan and Kanchana for this great opportunity. And also, Dimutu for your support as well. And also, as I know, Chamod, Tushanta, Samira for your effort, because those who are the behind the scenes supporters. So thank you very much. Yeah. Uh, any questions?
Yeah. If you have questions, please drop them in the chat.
So,
So far, we don't have any
anything
questions.
else?
Yeah. Let's wrap up the session then. Thank you very much, Camila, and thank you for everyone who attended to today's Kubernetes Sri Lanka meetup. And see you next time. Stay safe. Bye.
Thank you, Chamu. Thank you very much.